Hi, alistairsenglish here. I'm here to talk about a project I've been working on called PepperJS. PepperJS is a JavaScript API and environment for building web apps that control SoftBank's Pepper robot. It's built as an Android application and runs on Pepper's Android OS. It is important to note that, as you'll see soon, whilst PepperJS improves on the Android development experience, it is also built on top of and leans heavily on the Android platform, which, without, PepperJS would not be possible. PepperJS is more of an extension of the Android OS rather than a replacement. So first of all, why web apps? Well, PepperJS was built to address a couple of key problems with developing Android applications for Pepper, especially within the context of Pepper being a commercially available robot. The first of these problems is accessibility. Take Joe here. Joe runs a small tech business. Joe has seen the Pepper robots and is keen to use one of them in his services. He's got enough capital and is willing to make the investment. The only problem? Joe doesn't know Android, and neither do any of his staff. How is Joe going to be able to build all the amazing things he's been dreaming up without wasting heaps of time and money? Well, what if Joe could use web technologies to build his Pepper application? He already has existing assets and a website that matches brand, along with a couple of web developers. Joe reckons he could figure it out pretty easily. The second issue is speed of development. Even the biggest Android wizard can't go from zero to a simple app in the time that anybody can whip up a simple but comparable website. Quite simply, it is much faster and easier to build a web app than it is an Android app. On top of this, it is far easier to build beautiful apps with decent UIs using web technology, because, well, that's what the web is designed to do. Web applications are much more suited to the event and data-driven, content-rich applications that are Pepper's strength. Take a simple store greeter application that shows the users the newest products in store. Why build a clunky, complex Android application when you could build a simple, data-driven website with complete access to all of Pepper's robot functionality that is simply served to Pepper when required? The third benefit is deployment. PepperJS's architecture makes deployment simple. Instead of worrying about signing Google certification and publishing apps on the App Store, simply publish your PepperJS application online as you would a normal web app and let PepperJS do the rest. Whether you have one robot or 1,000 robots, all that is required is a one-time installation of the PepperJS app. From there, your Peppers can be pointed at any PepperJS application in the world. So how does it work? Well, using PepperJS is easy. By including the Pepper JavaScript library in your web apps, you get access to Pepper with native JavaScript functions such as say, listen, and go-to translation. These can be called from wherever you like in your app. Simple, right? To demonstrate this further, and to show off the PepperJS app itself, I'll now do a demo of an example application made with PepperJS to play chess. I'll have a quick look at the code, and then show you the on-robot end-to-end use of PepperJS and what the final chess app looks like. All the code for this example can be found here. Alright. So I'm here in the codebase of the PepperJS example chess app, and as you can see, it's a simple web app built with static files. If we open up the index.html file, you can see here we've imported our PepperJS library, along with a support library that emulates Pepper when the app isn't running on a robot, as well as some other JavaScript chess libraries, jQuery, and Bootstrap for styling. Opening up the index JavaScript file, which is the main driver of this app, most of this code is logic to run the chess game, but I want to show you a quick example of a Pepper say usage in code like this one. So this is just before Pepper is about to make its move, and here we are randomly selecting a string from a list of predefined phrases that we want Pepper to say at this time. After that, we're defining a callback function that is executed once the say is finished. The say could end with 3 different states: successful, cancelled, or error, and the result object that is passed into this function contains this information. So once Pepper has finished saying her move phrase, then we execute the rest of this function, which contains the chess move logic. If we jump over to the play again JavaScript, this code is for another page, which is displayed after the game is over, asking the user if they want to play again. When the page loads, we have Pepper prompting the user here, and then we also have a listen that we run to listen for user responses. In this case, we pass a JSON array of objects with an ID and a list of phrases that we want to match for under that ID. When a match is found, the callback is called, and the ID of the match that was found is stored in the result object under match ID, as well as all the other completion information that the say result has. That's all I wanted to show you in the code. Let's now go and take a look at the app in real life. So this is the PepperJS app, and as you can see, we've got some sites defined in a list here. Clicking launch on any of those sites will launch the site on Pepper inside a JavaScript environment that gives the app's code, like the code we just looked at, access to Pepper's robot functionality. So what I've done for this demonstration is spun up a Python web server on my laptop that is connected to the same network as Pepper. Then, I've simply created a new connection that points PepperJS at my laptop. When I click launch,
"Hi, let's play some chess. You start."
The code we looked at just before is served to Pepper over the network and run on the robot. Let's now see how I go at some chess.
Wow. Pawn to f5. You're up. I like it. Pawn to f4. Your turn. Oof. Pawn to d5. Your go.
So as you just saw there, that was our chess app using a couple of says. For example, just before Pepper moves. So what happened was, the say was called, and then, on completion of the say, its callback was called, and the application logic continues. In that case, Pepper made a move. So luckily I won this game, and Pepper recognizes this.
Checkmate. Wow, you win. Do you want to play again?
Yes.
Excellent. Hi, let's play some chess. You start.
And then the web app directs me to the play again screen, where I respond to Pepper's prompt and Pepper is able to react accordingly. As you've seen, PepperJS is all about making the robot app part easy, so you can focus on the important part, making amazing things with Pepper. That pretty much completes my PepperJS demonstration. If you have any questions at all or are interested in the project, please get in contact with me, Alistair English, via email at alistairsenglish@gmail.com. Thanks for watching.